Hello guys and welcome back. So this is a quick sim. I think it took 4 minutes and it's quite high res. If I go to frame 35, yeah, it's getting to the high res level, and it only took 4 minutes for this to compute. And this is the result. As you can see, we don't have any more mushrooms shapes, which is the primary thing that we needed to finish, and then we have a lot of interesting details that are not disturbing or destroying the shape of the sim. Now this is done using a low res setting for the viewport, and I'm going to show you how it looks like at a higher resolution. So I'm going to select the visualization node. I'm going to turn on the max vis res, and we should see it change in a few seconds. And what I've done as well is I went ahead and changed the smoke solver settings to use BFECC, and I've run a second sim that I will show you guys. And this is the resolution. As you can see, we have a lot of shapes, we have a lot of interesting details, and this is again coming from the mixture of all the noise patterns that we've applied. And this is where you guys have to experiment a bit to create your own pattern, and honestly just using this is generally enough, but if you want to create something very unique in terms of look, you can definitely do that. And we're still going to learn a lot of techniques to how we can add details even further to this. Now I'm going to show the BFECC one. I think I only simmed 30 frames of it. Yeah, only 30 frames. Let's take a look. It's quite different than, let me turn off the high res. It's quite different than the original one, but it has more details. Cool. So let's take a look at the resolution and compare them one to one. Set this to 1024 just to be consistent. And we're going to look at the same frame. Now what I recommend doing is always use the final smoke solver settings. If you're going to show it in dailies or anything like that, always show the final settings, the final solver settings, including doing a high res sim. There is a high chance that if you show anything different, anything that is not the final settings, if you show a mid-res sim or anything like that, that it most likely when you go to a high resolution it's going to change. So you have to get the approval on whatever the final settings is and use that. Now this is the BFECC one. You can see it has a lot more detail. It has what I'm really happy with overall. You can see here there's a lot of broken up shapes. See them here. This is another big block. This is another big block. And then each one of them has recursively more details. It's not like it's much more rich visually than just the classic noise, which is a uniform pattern that gets applied to the smoke. And this is coming from within, let's say. And I think there is even more resolution. Yeah, I think that's pretty much it. But let's say this is a mid-res sim. We're gonna see it like this. I think the resolution is really good for this element, and this is the part that I showed at the beginning, that you don't have to have a super high res volume to display the data. Look at how fine the details here, and this is just a viewport. Look at how fine the voxels are when we look at them from this angle. And this kind of level, there is nothing further, there is nothing more that you can get out of that data. Even if you're going to do any kinds of texture to add, let's say we have fire, you're going to add texture with noise, you're not going to be able to split this environment, that screen space into finer details. You're going to get just noise beyond that level. So sometimes you don't need to go crazy in terms of details to get a rich visual. I think most of the time mid to a high res sim, when I say that, basically without reaching 800 or 750 for any of these, okay, that would be the max. With that resolution, we should be able to get a lot of interesting details with this technique. And let's compare this with this guy. Let's Turn on. Obviously, the BFECC with the multi-grid resolution set to 2 is going to capture a lot more details. And let's see, I'm going to try and let me transform this. I'm going to put them side by side. And I'm super happy with this, the way it turned out. I think the main characteristic that I'm looking for is breaking up the mushroom shapes. Sorry, this is faster. The primary thing that I'm looking for is breaking the mushroom shapes and then getting a lot of details without having to go to the high-res quality, without having to create a high-res volume, and then having a interesting detail that follows the curvature or the shape of the volume. So those are the primary thing that I was aiming for. Let's view them side by side now. Yeah, you can see here there's a lot more detail. You can see the noise, and that's because of the because of the divergence running twice. It captures a lot more detail. Cool. So what I want to talk about in this video, we're gonna start the first part, and then we're gonna continue in the next one. I wanted to create some interesting masks to mask the noise that we have. Okay. And I'm gonna go back. Let me cache a few frames quickly. This shouldn't take too long. I wanted to explain a few things. So right now the noise that we have is being applied across the entire sim, and I wanted to create an interesting mask that we can use to modulate different noises. We're going to first use it to tune where this noise is happening, and then we can use it later to drive other things or control certain parts of the sim differently. Okay, cool. So I'm going to stop there, and I have imported the actually I need to import the val as well. Okay, so I have the velocity, the density, and the velocity both imported, and the idea is we're going to compute the gradient of this. Let me sketch something. So let's say we have the explosion like this. This is the silhouette, and we compute the gradient, which is basically a normal from every direction. Okay. Now this has a velocity as well, and in this case it's moving in this direction. So the velocity is going to be like this, like this. In some cases it could also be, this section for example could be going backward or could be going outward in this direction. So we have a velocity overall, and what I'm going to do is I'm going to compute the dot product between the velocity vector and the gradient, which is the normal. So if we have a part, let's say this guy, we have it moving this way, and we have its gradient moving, we have this gradient aligned in this way as well. When I compute the dot product, if the gradient and the velocity are aligned, we're going to get a value of 1. If they're completely opposite, we're going to get a value of -1. And then in between, it's going to be this range, between 0 and 1. Between -1 and 1. And we're going to use this information to create a ramp, so that when we have stuff that is facing backward compared to the velocity, we're going to give it a green color, for example. If it's 90-degree perpendicular, if it's at the center, it's going to be blue. If it's aligned to the velocity, it's going to be red. Okay, and then we have 3 floats, RGB. We can use that information to modulate the noise or anything we want. And this is going to be very interesting because this mask is not built of anything coming from outside. It's within the sim. So anything that happens to the sim is going to nicely and smoothly update all these fields together. So we're not going to see any jumps. We're not going to see anything popping. Everything is going to evolve naturally. And we're going to build a loop where let me see if I can how I can explain this. So let's say we have a smoke that is like this. Okay, we compute it. We compute the velocity and the gradient. We have a mask that isolates certain part. We apply a noise to only certain parts of it. Let's say these guys. In the next frame, it's going to be like this. Okay, for example, just an idea. We're going to run the same loop. So now we have velocity going this way. We have gradient going this way. For example, it's going to isolate certain parts. And it's going to run a recursive loop. So whatever the result that we're going to create, it's going to affect the sim itself. So it's going to feel like it's bubbling or rolling automatically. Anything we do is going to be rolling and following the curvature of the mesh, and we'll see. The curvature of the volume, and we're going to see more of this as we progress. Okay, let me explain it in SOP. So what I'm going to do is I'm going to convert this into a VDB so we can work on it easier. And then when we convert this float, these three guys, which is the velocity, into a VDB, we need to merge the vectors because we want to get a vector float that represents the velocity. And we use a VDB vector merge for that. So now we can see it's a three float. Cool. So the next thing, I'm gonna analyze the density and compute the gradient. And let me just isolate the density field. And let's analyze it. Why is it called Pyro? Delete non-selected. And we should be good now. Okay, let's give it a custom name. It's grad. Cool. And I'm gonna name this. I'm gonna change the name of this, and I'll explain why. I'm gonna change it to color because I need some color to display the result to you guys. Do I? No, I don't have to. I can do it in the visualization node. Cool. So we have the gradient, we have the density and the velocity. Let's create a volume VOP, and let's merge all these guys together. Okay, you can see now the gradient is visible here, and we can use actually it shouldn't be visible. Let me change the viewport. We can use a visibility node. I doubt that it's visible. We can use a visibility node to hide it. And we can also use a visibility node to hide the velocity if it's showing up. I think there is a glitch in the viewport. Let me close it and reopen back. The visibility node just hides the primitives from the viewport. There's something else here. Okay, that's the gradient. Let's hide it. Okay, I'm not gonna bother. So I'm going to dive inside the volume VOP, and we need to import those guys. So let's import the velocity. It's a float, a three float. Let's import the gradient. I'm going to normalize both of them because I don't need any magnitude for any of these guys. And I'm going to compute a dot product. And I'm going to export it back. It's a float, so let's create a copy of the density field. I want to create a field specifically for this. So I'm going to change the name of this guy. I'm going to change it from density to, let's say, dot product or dot result. And let's merge all these guys, and then I'm going to export it as that. Cool. So now we have our fields. And let me add visibility. I still think there's an issue. So I want to just display that. I'm not sure why is that. It's definitely hiding something. Okay. I'm gonna put down a visualization node, and I want to show that the dot product that we computed as a color. So using a visualization node, I'm going to specify the density, and then for the color, for the diffuse field, I'm going to set it to dot result. And then here, I'm going to tell it the range goes from -1 to 1, and then let's say white to red. Yeah, and there is an issue, which is not a problem. I think we'll understand the idea quickly. So I'm going to set this to red, green, and blue. I know why. Because I clicked one of these like this. That's what was happening. Sorry guys. So now let me go back. So this is the volume. We computed the dot product between the velocity and the gradient, and this is the result. This is the display of that. Let me increase the density. You can see we have red where it's facing, where the gradient is aligned with the velocity. We have it pointing backward, which is the green. The green is the center here, and then we have the blue, which is facing this way. Now let's go back to the first frame. You can see here the velocity, we have some velocity, so it's probably pointing, the velocity is pointing this way, that's why we're getting red, and then all this is the result between those two things. And as it starts growing, you can see the mask is nicely following the shape of the explosion, and sorry, of the smoke. And let me show you guys something. Now in the viewport, there's this hidden feature here for color correction. You can click that, and then if we click on red, you can see we can see the red channel. This is the green channel, and this is the blue channel. Okay, and these are all the masks. Let me make sure this is off. Cool, so those are the three masks that we can use. In the next video, we're going to start applying this and creating this in DOPS. So we have all this data available for us in the gas VOP, and then we're going to use that to modulate the noise that we have. Thank you guys for watching, and see you in the next video. Bye-bye.